Here we've got a Clinton shortwave radio from the 1930s. It's got the normal broadcast band and then a shortwave band from 2 to 7 megahertz. I've had this for more than 50 years. My father got it for me when I was about 12. Not sure where he got it, but it was on my bedstand playing AM rock and roll all through high school and until I went off to college. I retrieved it from my parents' garage about 20 years later, but never used it much after that. The wood cabinet's a little worse for the wear. The worst part is some cracking here on the veneer where it bends over the corner. And the same thing on the other side. But otherwise, it's not too bad. There's a tiny crack in the dial cover. I think that was there when I got it. I love the Art Deco numerals on the dial, though. I don't think it's been turned on in about 30 years. The controls are all frozen. It's a model 621XQ. Let's turn it around to the back. This is the antenna. You just string this around your room. It's cloth-covered wire and it's completely shot. Bare spots all over the place. The odd thing about this radio is that the heaters are wired in series, but it does have a power transformer just for the B+. So it's got a 25Z5 rectifier and a 25 volt 43 output tube, plus a ballast tube. And here's the B+ power transformer that I replaced when it burned out about 50 years ago. Let's see if we can get the knobs off. They're held in with set screws. There's one felt. I'll bet that's original. Let's flip it onto the back. There's just 3 screws holding it. Looks like they're the original screws. They're all the same anyway. Okay, let's see if we can get it out. It's hung up on a little block in the bottom corner there. Maybe you have to lift it over top. There it comes. There's the tuning capacitor. It looks like a midget IF can. I don't know why that's so small. There's some extra unused holes, so they must have used this chassis for several different models. Let's turn it around. Looks like the speaker's in pretty good shape. There are a few tears that have been repaired, and one tiny hole, but not too bad overall. There's the power transformer again. It's wider than the original, so it's only held in by one screw. Let's flip it over and see what's on the bottom. There's an extra transformer I put in 20 years later to boost the B+ voltage. I think it was 25 volts. Here's a big capacitor, 100 microfarad at 450 volts. Looks like another 1980s modification. I'm sure they didn't use anything like that in 1938. But plenty of old original wax capacitors. That's got to be the oscillator coil. There's a capacitor to nowhere, and that green capacitor looks like it's a replacement. There's 2 more 1980s electrolytics on the rectifier tube, wired in with duct tape. 100 microfarads at 160 volts. It looks like they're wired in series, so maybe a voltage doubler. I don't remember doing that, but I must have done it. Nobody else ever worked on this radio. Clearly I was on a quest for higher B plus voltage. So I think what I have to do is trace out the circuitry and try to figure out what I did here and what the circuit was originally before I power this up. Meanwhile, let's see what we can do about these frozen controls. We'll start with the tuning capacitor. I'm just going to shoot some WD-40 into the bearings here. And then the same thing on the volume control and the band switch. To see if we can loosen that up. I'll just let that set for a few days and see if I can turn it. I traced out the power supply circuit, and sure enough, it's a voltage doubler fed by the two transformers in series. But I'm pretty sure it wasn't a doubler originally. Here's the original B plus supply as I remember it. It was a simple half-wave rectifier fed by a transformer with a single winding, with both ends of the winding being rectified. Now I remember wondering what the point of that could be, possibly to drop the voltage to the desired level. I never knew what the original transformer voltage was, since I didn't measure it before it burned out, but I replaced it with what I thought was a simple one-to-one isolation transformer, and I used it like that for many years. But I vaguely remember that when I rescued the radio 20 years later, I tried running it with an external B+, and found it worked better with a higher B+ voltage. So that must have been when I converted it to a voltage doubler. I've measured the secondaries of the existing transformers, and they add up to 126 volts, so the doubler ought to yield roughly 250 volts DC, which seems awfully high, especially since most of these old capacitors are rated at 200 volts. So I think to start with, I'm going to disconnect these transformers and run it on a lower B+ from an external supply. I looked for information on the 621XQ model online, but the only thing I could find is this one page on Radio Museum. It has this picture, which is definitely my radio. It has the year 1938, and it has a number of tubes, 6, but that's about it. I've looked at schematics for a bunch of other Clinton radios, but I can't find any that use series heaters and a B+ transformer. Here's about the closest thing I've found, the transformerless model 145 from 1936. It has most of the same tubes, and like every Clinton I've seen, it gets the grid bias for the output tube by running the negative side of the high voltage supply through an inductor. But in this case, it's a separate choke, not the speaker field, and has almost 4 times lower resistance than my speaker field. So the full voltage drop across the coil is used for bias, whereas on mine it goes through a voltage divider. So it's not much help as far as reconstituting my power supply. I've managed to trace out the rest of the radio's circuitry, and it's actually a pretty unusual design. Besides the odd power supply, it's got this anode bend detector, where instead of using a diode, they put a very strong negative bias on the audio amplifier tube. You can see they're using a 25K resistor on the cathode, which will bias the grid close to cutoff, so the tube only conducts at all in the positive half of the IF waveform. So on the plate of this 76, you've got basically a rectified IF signal with an audio envelope. This .002 capacitor shorts the IF to ground, and you're left with the audio signal going into the output tube. These anode bend detectors were very popular in radios from the 1920s, but it's pretty rare to see one as late as 1938. And the volume control isn't even in the audio section. Instead, it's back here in the RF-IF section. And what it does is adjust the bias on the mixer and IF amplifier tubes by varying a shared cathode resistor. Finally, it's got this huge 5 megohm grid resistor shared by the 76 and the 66, which I suspect is an automatic volume control. The 76 normally has high negative bias, but if you get a really strong IF signal, it will push the grid more positive than the cathode, And then the grid could act as a diode and start accumulating a negative charge on this grid bypass capacitor. That would increase the negative bias on the 6D6 and reduce its gain. Other than these oddities, it's a typical 4-tube super heterodyne layout. Okay, so it's the next day, and I have made some progress here. I can turn the band switch back and forth pretty easily. I can turn the volume. The tuning is still pretty tight. But I put a little pressure on the capacitor. I can turn it. So I'm going to shoot the capacitor with a little bit more WD-40. Leave it set for a while. Just see if we can get it to the point where I can turn it with just the knob. Okay, I'm going to leave that set another day. Come back and see how it goes. Okay, so I've disassembled my Frankenstein power supply. Removed both of the power transformers. There you can see the outline of the original transformer, and looks like in some other models they must have put a tube there. I've also cleaned up some of the dust, just some alcohol and a rag, and now the tuning turns quite freely through its full range of motion, just from putting on WD-40 and working it back and forth. And I've also covered the speaker with cardboard so we don't put a finger through it. And we're just about ready to power this up. Okay, so again we're going to fire up the filaments separately, and for that I have this variac so we can bring the power up gradually, and then plugged into it is a power meter, and then the radio is plugged into that. And then for the B plus we have this power supply which can measure voltage and current, and then this meter is going to measure the voltage going to the plate, that is the B plus voltage, after it's gone through the speaker field. And then I've got the aerial just running up into the upstairs hallway. And so let's give it some filament voltage. Turn on the variac here. And that's running at 53 volts. You can see the dial lights glowing. So let's go ahead and bring that up to full voltage here. Okay, that's 112. Current 315 milliamps, so that should be good. And the dial is glowing quite brightly. And I can see the filaments glowing. Oh yeah, you can see that on the camera. And we're ready to give it some B+. And it's doing something. That's 70 volts. Let's try to tune this. Let's try the other band. Maybe this is the broadcast band.
Williams. Of course, I'm talking about Sarah and Debbie Reynolds. The Reynolds team at Keller Williams.
So we're definitely getting something, and this is with only 80 volts of B plus on the tubes. I'm sure it's supposed to be a little bit higher than that. Let's go to 150.
While maximizing the sale of your home. They did this for Mauricio. Mauricio had a townhouse. They sold his townhouse. May have been the best quarterback of the 4 winning quarterbacks this weekend is what the silly nonsense that I was talking about. It may just been watching that game because, you know, the what ifs.
And there's a sports station. That's 950. Okay, let's turn this off. But great, the radio is working after 30 years. Now I think the next task is to just replace some of these old capacitors and then try to align the radio, get it working really well, and then try to deal with this power supply problem. Okay, so I've come back in the evening here just to see if we can get anything at all on the short wave band. Got the filaments on, just about to turn on the B+. Okay, switching now to the short wave. And where we'll expect something is at the high end of the dial, around 6 megacycles. Well, there's something.
He removed that barrier. He paid the price, as the parable says, to purchase the whole field, which is the world, everybody in it.
Sounds like a religious station. Sounds like Chinese. Okay. So the short wave band is working as well. A lot of interference. I'm not sure whether that's alignment or just a lousy antenna, but at least both bands work. Okay, so we're back on here on the broadcast band, and 2 things I've noticed. One is how low a voltage this radio will actually work on. So here we've got 31 DC volts total and 25 volts across the plates, and that's enough to operate the radio. Anything lower than that and it kind of cuts out. But the second thing I noticed is how much of the voltage, turn this down, how much of the voltage is falling on the plates and how little on the speaker field here. So if we turn this up to, say, 130, on the plate circuits, so there's only about 30 volts on the speaker field, which is less than I expected. If we look at the current, only 24 milliamps going through the receiver. Now I'd expect at least 30 milliamps just from the output tube, so that seems really low to me. So I don't have a tube tester, so what I'm going to do is try to test this output tube in circuit, see what the cathode emission is, and see if that matches the specifications. Here's a data sheet for the Type 43 tube. It specifies a screen grid voltage of 95 volts, and then these plots show the plate current as a function of plate voltage for various constant values of grid bias. Here's the curve for a bias of -5 volts. So those conditions should be easy enough to duplicate in circuit. We can fix a control grid bias easily enough, and then the screen is connected directly to B+, so just set that to 95. If we measure the DC resistance of the output transformer and then measure the voltage drop across it, we can calculate both the plate voltage and the plate current and see whether it matches the specifications. Okay, let's just measure the resistance of that output transformer. So I've got one clip lead on the B plus here, and turn this to 2000, and this is the screen, so that's 0 going directly to the B plus, and then this is the plate. So 350 ohms, that's the resistance of the output transformer. Okay, so we're just about ready to do an emission test on this 43 output tube, and we're going to try to duplicate the conditions in the spec sheet, which are the control grid at -5 volts. So for that, got this old zip drive power supply, puts out exactly 5 volts DC, and I've measured that. So we'll just plug that in. And that's connected to the ground and then to the control grid of the 43. So we'll clamp it down at 5 volts. Filaments are on. And so let's just crank up the B plus here. And the spec sheet specifies that the screen grid should be at 95 volts. And here the B plus is connected directly to the screen grid. So just crank this up to 95. Okay. And now I'm just going to move this voltmeter lead from the ground here, and then just connect it to the plate. So there's 5.2 volts now across the output transformer. Okay, so 5.2 volts divided by 350 ohms. 15 milliamps. So if we look at the data sheet with about 90 volts on the plate, we should be getting a current of about 45 milliamps. In other words, we're only getting about a third of the expected current. So we might consider replacing that tube. Okay, so another tube we can check is the rectifier tube, also a very hard-working tube, and easy to check because I've disconnected the whole power supply. So again, I've got the filaments on, and I've got positive terminal of the power supply simply connected to the plate, negative terminal to one of the cathodes of the rectifier. And looking at the spec sheet, we know that at 25 volts between the cathode and the plate, we should get a current of about 180 milliamps. So I'm just going to turn on the DC here. Crank this up to 25 volts. And then just check the current. So 165 milliamps, a little bit below spec, but not too bad. Okay, I'm going to set this up to the other plate and check it again. Okay, so now the same thing. We're connected to the other plate and cathode, and I've got another voltmeter here just to check the voltage. Let's turn the filaments on. Okay, DC on. This says 25, this says 25. And the current, 195 milliamps. Okay, so that's good. So no problems with this rectifier. So here's today's mail. I think this actually might be my tube. Nice how they just balanced it on the mailbox door like that. Okay, I've got a brand new old stock Sylvania Type 43 tube here. And some people claim it's advantageous to precondition these tubes by running with the filament only for 24 hours before you actually put the B plus on. So I have been running this for a little bit over a day. My 25 volt supply here. And we're ready to put this in the radio and see if it makes any difference. Okay, so just to recap here we're running with the old tube. We've got 121 volts going in, 95 volts on the plate, and the current is 21 milliamps. Okay, I've got the new tube in now. Filaments are on. Let's apply some B+. Just cranking the plates up to 95. Now you can see this is much higher, 166 volts. It was more like 122 before, so clearly more current going through the tube, creating more voltage drop across the speaker field. And if we look at the milliamps now, 60 milliamps, so almost 3 times as much current going through the new tube. So let's see if we can measure the voltage drop across the output transformer here. .3 volts, which is 3 times as much as the old tube. Okay, so 16.3 divided by 350. 46.5 milliamps. So that's right on spec. That's a really good tube. And again, the old tube was really worn out. Okay, well, so far we've done 3 capacitors in the audio section here. And I've got it on. We're still working here.
With Riz piping into the left short corner, Walker finds orange 3 left wing. That's no good. A hand in his face.
Here's one of the old capacitors. Looks pretty awful, but actually it still measures 0.1, and I don't have a leakage tester. But in any case, just going to continue here, trying to replace these capacitors. We're still on external B+ here. So these old capacitors, they always show with a black band here which side is the outside foil of the capacitor. And modern capacitors don't show that, and a lot of controversy over whether it really matters on a modern capacitor, but we're going to try to determine the outside foil here. So I have this just connected to an oscilloscope. It's on the most sensitive setting, which is 5 millivolts per division, and if I just hold it here by the shielded cable, there's no signal at all. I grab the capacitor with my fingers. There's maybe a trace of hum. So let's turn it around here. And now there's quite a bit of a distinct 60 cycle hum there, maybe 1 millivolt or so. So that means that the hot lead must be the outside foil here. So just mark that on the capacitor and put it in the same orientation as the one I took out. So I'll just continue that with all these capacitors that I just bought. So we got these capacitors out. Try to deal with this loose IF can. One nut is missing and the other one is loose. So just find a nut and tighten that up. Okay, now we got both nuts on, nice and tight. Okay, so those two yellow capacitors, that's the screen capacitor and the cathode capacitor for the 6T6 and 6A7 in the front end. And those were the two most difficult way down there on the bottom. And the radio is still playing. So just finish up the rest of these wax capacitors here. Okay, I've got all those wax capacitors replaced now, all 10 of them. And the radio is still working. I wouldn't say it works any better. Seems to be about the same. Just have this one electrolytic now. And I think we'll deal with that later when we rebuild the power supply. I posted an inquiry to the forums at antiqueradios.com just asking whether anyone else had seen this model of Clinton radio. And I got some very useful replies, including alignment procedures for a similar Clinton radio with the same two bands, the same front end tubes, and probably the same set of coils. Here it is, and it's pretty straightforward, but also pretty laborious and time consuming. So I think I'll post that as a separate video. Okay, I've completed the alignment, so let's see what we can pick up. Well, there's still a lot of interference here in the upper end of the broadcast band.
4 reasons who are most vulnerable and
There's some stronger stations down here in the middle of the band.
for everything from servicing your office or retail lighting to emergency repairs. And they can help you save.
Well, so far I've been pretty disappointed in the performance of this radio. All that work and alignment, and still only gets the same 3 or 4 really strong stations, and otherwise pretty much overpowered by interference. So I tried my car radio, and it gets about 20 stations real clear. So I decided to bring this radio out here away from all the modems and routers and switch mode power supplies in the house and see what it could do. So we're going to power it directly from the electric car battery, which by coincidence just happens to be 120 volts, which is perfect for the filaments and seems to be fine for the B+2. So it's just wired directly to the battery here. So let's give that a try. Wait for that to warm up. I've just got the aerial here strung up into a tree there. And make sure this is on the AM band. Certainly never got that station before.
That we have recorded in the epistle. That we have it in the Gospels, his direct word. Have it in the book of the Revelation.
Federal civil servants. It's not a critique of any particular person. It's a critique of a system that was not designed for
The way to hoping at El amor solo puede durar toda la vida si es incondicional. Es decir, el que no se fundamenta en las circunstancias o los sentimientos. Heaven knows I tried. That's when my heart knows that I've lied.
That's a classic rock station, probably the only thing I'd really actually be interested in listening to.
Oh,
Apostle John by the 2nd and 3rd century writers.
Be presented with product links. I mean, but it makes sense. How often do you look at YouTube videos and say, oh yeah, I'd like to that, or I think I should buy that?
Just want things to be a little simpler and safer. That's why we offer safe and easy ways to file your taxes. Securely drop off your documents with our skilled tax pros. Request a pickup and we'll come to you. Or upload your docs and work with a skilled tax pro from the
Able to add additional draft value.
Today at 10838 West Broad Street in Glen Allen and test these products for yourself. Visit their website at rvabanking.com.
I think that's the country station.
Most broken life. Today we bear witness through salvation.
Okay, so what a difference. So I think basically the radio was working as it was designed to work, and it just wasn't designed to work in a house full of electronic gadgets. Of course, I tried some newer radios. They didn't do much better. And if I actually want to use this, I might have to come up with some steps to either eliminate some of this interference or filter it out. Okay, so it's a couple of weeks later. I've made some progress on dealing with this interference problem. I've also wired up temporarily a power supply on the radio with this just a 1-to-1 isolation transformer, and then that going into the 25Z5 as a half-wave rectifier. So I've got it powered up. I've got it plugged just into an extension cord from the house, and then again the aerial is that same single long wire that came with the radio. So under these conditions we can get
this is a bad guy.
We can get a few very strong stations. But if I try to get my classic rock and roll station here, it does come in, but it's so much interference that it's really just unlistenable. Okay, so a couple of things I've done to try to reduce the interference. One is I made up one of these tunable loop antennas. You can find directions for these all over YouTube. A lot of guys have done this. This one is just 2 foot square. It's 9 turns of number 22 wire, and then linked to a 365 picofarad capacitor, and then a smaller pickup loop, just 2 turns of wire, and the pickup loop is connected then to this coax, and then the coax is going to the radio. The reason I'm using the coax is when I actually use this in the house, I think this is going to have to be in a remote location, like a far corner of the attic, away from all the electronic stuff. And then the coax here is connected to the antenna and the ground connection on the radio. And I've also added one of these little interference filters, so-called EMI filters. This is a couple of chokes and capacitors supposed to filter out radio frequency noise from the power line. Now, experimenting with both of these, most of the improvement is from the antenna, but this really does help as well. So I've got that same station tuned in, and now there's almost no interference. So I'm going to try to set this up in the house, see if it works just as well, and then again start experimenting with the power supply. Okay, we're back in the house, and I've been working on minimizing hum and electronic interference. I started with a pretty serious 60-cycle hum, so to trace it, I first tried shunting the grid of the output tube to the ground with a 0.1 capacitor, and that eliminated the hum completely, so it wasn't arising in the output tube. When I instead shunted the plate of the detector, there was still an audible hum, suggesting that at least some of it was coming from the grid bias supply. So I tried shunting the middle of the voltage divider to ground with a 3 microfarad electrolytic, and that also eliminated most of the hum, so it clearly was coming through the B- supply. Then I started to wonder about this 0.25 capacitor, because when I replaced it, I initially had it connected to ground, not to the B- supply, but I later switched it after checking against my schematic. But now I think I had it right the first time, and I somehow got it wrong on my schematic, because there's no reason to put a capacitor here. All it would do is shunt the power supply ripple to the grid bias supply. We don't want that. So I moved the capacitor connection back to ground, and that eliminated most of the hum, but not all of it. Now with my temporary power supply, I've got 2 power cords, the original that goes to the filaments and a separate cord to the B+ transformer. Surprisingly, the hum now seemed to be coming mostly from the filaments, because briefly unplugging the filament cord eliminated most of it. Also, flipping the plug around, there was quite a bit less hum when the detector film was connected to the neutral side of the line, and more hum when the plug was reversed. Now, there used to be a 0.05 capacitor between the ballast tube side of the power line and the chassis ground, but I removed that years ago because it seemed to actually increase the hum, and that still seems to be the case now. But a capacitor from ground to the other side of the line, which connects to the detector filament, further reduced hum. I don't fully understand why it does that, but I think what I'll do is move the grounding capacitor to the detector filament side of the line. I'll also put a polarized plug on the cord so it's always plugged in to minimize hum. This one's chipped and worn out anyway. You can see how loose the prongs are here. I've been working on minimizing interference here. One thing I've done is go around the house and try to identify some of the worst noisemakers in the house. And here's one of them. It's a replacement power supply for a laptop computer, and it's very noisy. And that seems to be a theme here, that these cheap replacement power supplies that you get on eBay are really terrible noisemakers. So I've left some of those plugged in just for demonstration purposes here. And for an antenna, I've got my tunable loop antenna. It's up in a corner of the attic as far away as possible from any electrical lines. And then that 100-foot coax is coming down here to the basement, and that's connected to the antenna and ground of the radio. Yeah, I got my same oldie station tuned in here. They're just talking, so we won't get a copyright hit. And you can tell it's pretty noisy. And since I got the 2 plugs here, one to the filaments and one to the B+, you can ask whether it's coming from the filaments by momentarily unplugging the filaments. So let's do that. So you can see way more interference when the filaments are plugged in. So it really does seem to be coming through the filaments. Now that's with the filaments just floating, no connection at all between the chassis ground and the filaments. So here's a capacitor, and this is connected to the detector filament side of the line. And if I just ground that capacitor, you can see a big drop in the interference.
Fabulous seafood boils like shrimp, mussels, clams, and more. You can even build your own combo. And don't forget to ask about their family specials when you're thinking seafood.
I was going to do that anyway because it also reduces the hum, but You just have to be sure to put a capacitor in there. And as far as I can tell, that's just as effective as putting one of these EMI filters on the line. Okay, and just to show the importance of my tunable loop antenna, I'm going to take off the ground connection here. So now we'll be just using this whole 100-foot coax as a long wire antenna. If I take that off,
It's called Bramley Park After Dark. $20 for 4 people to get in tonight.
the signal is actually quite a bit stronger, but there's much, much more interference. So I really do need that loop antenna at a remote location. And just to show that it's not something wrong with the radio, here I've got a portable radio. It runs on batteries, so it's not connected to the power line at all. And there's the same station. And it's just terrible reception down here is the problem. So a few other things I tried that didn't really make much difference. A capacitor across the line didn't help at all. I tried grounding this directly to an earth ground. Sometimes that helps a little bit, sometimes not. I've also tried grounding to the ground connection of the power line. Sometimes that helps, sometimes it does nothing, sometimes it actually makes it worse. So I guess it must depend on exactly what the interference is and where it is on the line. So I think I'll stick with just a two-prong plug. I'll put in this capacitor and keep my loop antenna, and that's how we'll deal with the interference problem. Okay, so we're still set up here. I've turned off most of the worst noisemakers in the house, and now the signal's coming in pretty clear. Really no interference that you can hear at all. So I'm just going to go ahead and wire this up, put in that capacitor, put in the power transformer, and then we'll see how it works out. So now I need to rebuild the power supply. Originally the radio had a transformer with a single secondary winding, which I assume must have been needed to boost the B+ voltage, but I don't know by how much. I'm guessing the original secondary was 160 to 180 volts, because this set of tubes was typically draw 40 to 50 milliamps. That would mean a 60 to 70 volt drop over the speaker field, so that would leave a little over 100 volts DC for the actual B+. When I found this isolation transformer from Triad for $11, I was pretty excited because the form factor exactly matches the original from the radio, and it can be wired for either 115 or 230 volt secondary. What I didn't realize is that these isolation transformers actually boost the voltage a bit to compensate for losses at full load. So with a 120 volt input and no load, this transformer's secondaries each put out 140 volts. So wiring the secondaries in series would produce 280 volts, which is way too high. I also just realized that when I put in this isolation transformer 50 years ago, I had the primary and secondary reversed. So instead of boosting a voltage a bit, it was knocking it down to 100 volts. So no wonder it worked better with an external B+. It's also possible that a high B+ was needed to compensate for the old weak output tube. But now the radio seems to work fine with two secondary windings in parallel. When I tried boosting the voltage further with a variac, it didn't make the radio work any better or play any louder. So I'm thinking I would just leave it wired as a simple isolation transformer. So then there's the question of which transformer to use. There's the new one that actually looks more like the original one that was in there that was mounted vertically like that. And it does fit the mounting holes. But on the other hand, you can tell it's a replacement. And plus it has these exposed contacts straight to the line and right in the back of the radio. And then we have the old one that was in there. And it certainly has more of a antique look to it. And it doesn't fit the mounting holes, but if I mounted it diagonally here, it would fit, and I can just drill a couple of new holes. And actually this one, if it's connected correctly, boosts the voltage a little bit more. This puts out about 140 volts as a simple isolation transformer. This one puts out 150 volts. So actually I'm sort of inclined to put this one back in. First, let's see if we can do something about this little hole in the speaker here. I've got an old newspaper here. I'm just going to blacken a little section of it here. And then cut out a patch a little bigger than the hole. Okay, there's my patch. And here I've got a dilution of roughly 1 part wood glue, 1 part water. And just going to try to daub a little bit around the hole here. And then just see if we can get this patch on. Okay, I think that should do it. Here's the final schematic, and except for moving the grounding capacitor to the other side of the line, I think it's the same as when it left the factory. Our line voltage here is always at least 120 volts, which is probably a little higher than it was in 1938. And the isolation transformer boosts it to about 144 volts under load. After rectification, I'm getting about 135 volts DC. The speaker field takes 55 volts, leaving 80 volts for the actual B+, which might be a little low, but again, raising it above that didn't seem to improve anything. Some people say you should check all these old dog-bone resistors and replace any that are more than 20% out of spec. Most of these are worse than that, more like 40 or 50% higher than the marked values, but most of them I don't think it's important. Like these grid leak resistors, their only function is to drain infinitesimal currents off the grids. So whether this is 70K or 170K, I don't think it really matters. This voltage divider might be more of an issue, but since both resistors increased more or less proportionally, it's not going to change the bias voltage. I thought maybe this cathode resistor would set the bias for the anode bend detector would be more critical, but I tried putting in a shunt to bring it back to spec, and it made absolutely zero difference. And the same with this screen grid resistor. So I decided to just keep all the old resistors. Okay, so we're all wired up here. I did go with the old transformer. And it turns out I only had to drill one hole. And I think that could actually pass for original, even though it's mounted on a little bit of a funny angle. And if we look underneath, it's a little bit less of a hack job than I did 30 years ago. At least everything's soldered and the splices are all shrink wrapped instead of duct tape. There's 2 new electrolytics. There's a 20 microfarad before the speaker field, and then 40 microfarad after the field. I kind of like these Sprague tubular capacitors. They have a real old-fashioned look to them, even though they're aluminum. And they even say USA on them. I don't know if I believe it, but that's what it says. And here's that square thing is the capacitor grounding the filament string. And it's a safety capacitor, which I mean, supposedly it can't possibly short out and give you a hot chassis. And then if we look at the back, I got a new grommet for the antenna and ground connections. This old grommet has really seen its day and then some. I've got a new historically correct cloth covered wire for the antenna, and the ground connection goes to this Mueller clip, which clips nicely onto my coax here, and then this goes to a 2.8 millimeter fast on or quick connect connector, and that slips nicely onto the inside terminal. And I got a reproduction polarized plug. Has a nice acorn pattern there. And of course the neutral side of the line is connected to the same side of the line as that grounded capacitor. Just put the cover on here. Well, obviously the cabinet could use some work as well, but I think that's going to have to be a project for another day, and for now I'm just going to put this back together. Okay, I've got some new felts for the knobs. Okay, we're all together. It's sounding pretty good now that it's back in the cabinet. Nice clear tone and plenty of volume. This turned out to be a lot bigger project than I thought. Maybe a lot of fuss just to hear some oldies on an old radio. But my father gave this to me half a century ago, and I really wanted to get it playing again while there's still something on the air worth listening to. In all those years, I never realized what an oddball design it was. It's got typical 1930s components, but a lot of the circuitry, like the anode bend detector and the volume control in the RF section, is a real throwback to the 1920s. They even have a reverse taper on the volume control, so they put some effort into building this thing. You have to wonder why they designed such a radio. Maybe a bunch of engineers having fun in the shop, just to show that it could be done. I don't know, but if anyone's seen this or a similar Clinton model, leave me a note in comments. I'm curious to know just how rare it is. And as always, thanks for watching.